This video is on Introduction to Logarithms. Let's first go over some vocabulary or pronunciation involving this. So the way you say this word right here, logarithm, let's break it into pieces. That's 4 syllables. Logarithm. These two are kind of said pretty quickly together. Laga, rhythm, logarithm. A lot of times this is shortened to just log. So if you say the word log, it means the same as saying the word logarithm. The way you write a logarithm, it has this sort of format where your B, M, and K here are all basically numbers, or can be numbers. And the way you read this is log base B of M is equal to K. So log base B of M is equal to K. Now let's go over what logarithm is mathematically. So a logarithm is defined relative to an exponential function. So if you see log base B of M equal to K, this means the same as this. So having a base B exponent K equal to M, and this right here is the same thing. So this base B becomes the base for the exponential. So the base of the log becomes the base for the exponential. This exponent K is on the other side. And then this M is this M. Okay, so if this is true, then this is true. And vice versa. They're like two ways of writing the same thing. Let's sort of look at an example of this. Let's say that we have this right here. Log base 3 of 81 equals what? And you were trying to say calculate what this is equal to. So this 3 right here is your base. So if I was going to write an exponent version of this, your 3 here would be the base for your exponent. This K here is you're looking for the exponent right here, looking for what exponent I would write there to make it equal to 81. So in this particular case, 3 to the 4th power equals 81. Therefore, log base 3 of 81 is equal to 4. Let's try another one. So, I want you to pause for a second, and I want you to write this in exponent form and try to solve for this. Hit play when you're ready. All right, so my base here is 4. The other side of my exponential function will be 64. And I'm looking for what number, if I put it as the exponent over here, would make 4 into 64. And 4 times 4 times 4 is 64. So 4 to the 3 power is equal to 64. Therefore, log base 4 of 64 is equal to 3, or has the same value as 3. All right, let's try one more together. So this is log base 3 of 1/3. I want you to write it as an exponential equivalent, write this as an exponential function, and then try to solve for that. Hit play when you're ready. So my base is 3. In the exponential, the 1/3 is on the other side. And I'm looking for what exponent would make the left side and right side equal to each other. And it is 3 to the -1 power that would make 3 to the -1 power is equal to 1/3. Reminder, negative exponents basically just move this to the bottom of a fraction and you have a 1 on top. So because 3 to the -1 is equal to 1/3, log base 3 of 1/3 is equal to -1. So as you can see, exponentials and logs are very much related to each other. So because of this relationship, because logarithms are defined relative to an exponential, and because an exponential has restrictions, those restrictions carry over to logs. So what do I mean by that? If you're looking at exponential, let's say you're looking at this exponential function, one thing we know is that your base for an exponential has to be positive and cannot equal 1. That's just a restriction on exponentials. So because this exponential, your base has to be positive and your base cannot equal 1, therefore the logarithm, log base b of m equal k, your b right here also cannot be 1 and has to be positive.